this discussion, I want to talk about numbering systems. Now, a numbering system is a method for naming or representing numerical values. And what that really means is it's a system of symbols that we have all kind of agreed will have a very specific meaning or a very specific designation. Now, in digital electronics, there are three primary numbering systems that we're going to learn about. That is the decimal system, which is also called the base 10 system, the binary system, which is also called the base 2 system, and the hexadecimal system, which is also called the base 16 system. If you go online or if you read through other textbooks, you'll find that they mention other numbering systems. They talk about BCD, they talk about gray code, they talk about octal. Those don't get used very much in the program here at school, and you'll come across them in certain cases where we'll talk about them individually later on, but we really don't want to focus on them in the beginning. We really want you to just focus on decimal, binary, and hexadecimal. As you can see here, each of these numbering systems has two names, and that's not because we're trying to make things complicated or confusing. It's because the common name is decimal, is binary, is hexadecimal. But when you're learning about these systems, those names aren't very descriptive. They don't help us understand how we calculate the values, how we convert the values. The base names are a lot more descriptive. They help us really understand what's going on in the system. So for example, if we look at the base 10 system, we're all very comfortable with the base 10 system. But what does that mean? What does base 10 mean? Why do we understand the decimal system? How does that relate to the idea of base 10? The 10 part of base 10 indicates that our system has 10 unique characters, and so that is 0 through 9. So as you can see here, we have 0 through 9. Now this is something that's kind of confusing in some cases, because notice that although we called it the base 10 system, that there is no 10 shown here in the numbers, that we only have 0 through 9. And that's because we started counting with the symbol 0. From 0 and the symbol 1, we can make the number 10, but notice that there is no number 10 in the base 10 system. It's a composition of two symbols from that system. Now this is really important because this idea of counting from 0 is something we do a lot in digital, and it's something that students often forget when they're implementing systems, is that we always start counting with the value 0. So again, try to keep that in mind as we're looking at this base 10 system. So now we can also look at the base part. So remember, it's called base 10. Well, 10 is the number of symbols that are in the system, but it is also the base in the calculation part. So when we look at the math part, this is a very important deal. So if we think about a number, let's say the number is 372. We read this number as 372. It's composed of three symbols from our base 10 system, the 3, the 7, and the 2. But how do we know that this is 372? Well, if we look at it this way, there is 3 in the hundreds place, the 7 in the tens place, and the 2 is in the ones place. But that still doesn't help us understand where these come from. Now, if we start looking at the base calculations, however, we start to understand where these positions come from, this idea of a hundreds place, a tens place, and a ones place. And so if we take a base value of 10 and raise it to a power of 0, that gives us a value of 1. Anything raised to 0 is always going to be 1. If we take a 10 and we raise it to a 1, well, 10 times itself is 10. That's where our tens place comes from. If we take 10 and we raise it to a power of 2, well, 10 times 10 is 100. That's where the hundreds place comes from. And so as you may have guessed already, if we go to 10 and raise it to a power of 3, we get a thousands place. And so this is how we create the numbers for our decimal numbering system. So if we want to prove that 372 is actually the value 372, we can use these base values to show how that might work. And so here we have 2 times 10 raised to a power of 0, which is the same thing as saying 2 times 1 is equal to 2. We could then take the next number in the sequence and say 7 times 10 raised to a power of 1, which is the same thing as saying 7 times 10, which would be 70. We could then look at the next number, which is 3, and say 3 times 10 raised to a power of 2, which is the same thing as saying 100. So 3 times 100 is 300. We then just add up all the values, and we get our 372. Now you notice that I added in here a subscript. Now the subscript helps us identify the fact that this is a decimal number. And so this is going to be very important in the beginning as you start converting numbers and calculating numbers to denote which system you are working in. And so in this case, we're working in the base 10 system or the decimal system. And so we put in a subscript to let everybody know that this is a decimal value.